After these few exhaustive lectures, let's take a quick look at some other interesting and easier functions that you may need at some point. If you have a matrix and you want to take its upper triangle and leave zeros below it, so if we have this matrix and you want to take the upper triangle, like this one, you can use the try u function to do this. So try u some matrix, let's run it, and we get the upper triangle. Let's save it in a variable, so upper triangle. You can take this same triangle, but you can shift it, like we did with the diagonals. So you can say upper shifted triangle, and you can say try u of some matrix, and you can supply a second argument that will shift the matrix by another diagonal. So if we say 1, we will go one higher, so we move the diagonal from which we start one up. If we say -1, we will take more information because we will start from the diagonal below our main diagonal. You can also take the lower triangle, so lower triangle equals to try L tricks. Let's run it, and we get everything below the main diagonal. Similarly, if we use the second argument, we can shift it, so try L some matrix of -1, we shift it down. If we say 1, we shift it up, like this. Alright, if you want to get all unique elements in your matrix, you can use the unique function. That function will return a column vector consisting of all unique elements in the matrix. So all unique elements equals unique of some matrix. Let's run it. Let's suppress these triangles here. We don't need them anymore. And there we have it. These are all of the unique elements in that matrix, not by rows, not by columns, simply all unique elements, and the result is in a column vector. Now, you can use the unique function to take all unique rows of the vector. So you can see here that the second row and the fifth row are identical, so they are not, this row is not unique. So we can say all unique rows equals unique some matrix of rows. You supply rows as a string argument. Let's run it, and now we get only 4 rows that are unique. So we are looking for rows that are unique, not elements, rows. It doesn't matter if these rows have shared values. Maybe they have exactly the same values, but if they are ordered differently, that makes them unique. As you can see here, the second row and the third row have the exact same elements, only the 4 and the 5 are switched here. So this is a unique row according to MATLAB. Next we have the isMember function. This function will let you check if a given element exists in your matrix or a vector. So isMember, we can say, first, this function takes 2 arguments. The first argument specifies what you are looking for, and the second, where are you looking for it. So I'm looking for the number 5, and I'm doing this in the some matrix. Let's run it, and this function returns a 1, returns a boolean. This function returns either true or false. So it simply tells you, yes, this element exists in that matrix, or no, that element doesn't exist in the matrix. So 50 doesn't exist there, so we get a 0. It doesn't tell you how many times it exists, it simply tells you that it exists. Now, you can use the same function to check if a given vector exists in that matrix. So is 5 a member? Alright, so is the vector a member? So equals isMember, open brackets, and here we can supply a vector. So let's just copy this vector. So 1, 2, 4, 5, 6, and 3. We are checking for that vector in the sum matrix matrix. And we also need to supply the rows argument as well. So we are checking if this row vector exists there. So let's run it and we get a 1. This vector exists. Now if I change this to something else, it returns a 0 because this vector doesn't exist. Not in that matrix anyway. And finally, the shifting function. This function, you can use this function to shift your matrix up, down, left, or right. So let's first see what shifting is. So shift equals circ shift. This is the function where you give it the matrix, so some matrix, and you give it a number that specifies how much you want to shift it. So if I say 1 brackets, and let's suppress these things here because I don't want them. Let's run it. And so this is our initial matrix. You can see here that the row 6, the row that starts with 6 is a 3rd row, and here it's down the 4th row. So we shifted the matrix down. You can see that the last row that was here is now the 1st row in the matrix. So this is shifting down. So if you're shifting down, you use a positive number. So let me copy this, paste it. If you want to shift up, you should use a negative number, like this. So you can see that now the row that starts with 6 moved up. Now our 1st row is our final row. You can also shift by more than 1. You can shift by 2 rows, by 3 rows, by as many rows as you want. You can also shift left or right. So let me suppress these. So shift left equals circ shift of some matrix. We want to shift by -1. Now the 3rd argument for this function specifies on which dimension we want to perform the shifting. By default, we're working on the 1st dimension, the rows. If we say 2, we're working now on the columns. So we want to shift the columns to the left by 1. And here we have 2, 3, 7, 3, 3, which was our 2nd column. Now it's our 1st column. It was shifted by 1 column to the left. If we use a bigger number, it will be shifted even more. So our 1st column was shifted 3 times to the left. It's now our 3rd column from right to left. And finally, you can shift to the right. So to the right is when you use a positive number on the 2nd dimension. So let's use 1 and let's suppress this. Let's run it. And 1st column now became a 2nd column. So you may find these functions useful at some point.